62, devo cambiare batteria, 62, yani 62'ye düşmüş.
Batarya mı hocam? Telefon mu?
Herhalde biraz.
Ne kullanıyorsun hocam?
Samsung kullanmaktayım. Batarya biraz.
Merhabalar.
Yani.
Merhabalar. Sesim geliyor mu?
Merhabalar. Ahmet hocam burada.
Efendim günaydın, günaydınlar diyoruz biz burada sabah. Sesimiz geliyor mu? Günaydınlar.
Günaydın. Sesiniz geliyor şu anda. Ben tekrar link çalışmıyor dedi Tolga Bey. Ona tekrar gönderiyorum. Yeni bir link kayıt oldum. Tekrar bir link gönderdi. Oradan girdim.
Merhabalar. Ahmet hocam burada. Ben şeyi kapatıyorum mikrofonu çünkü şu an yayına başladık. Lütfen ekranı da kapatıyorum. Saat tam 12'de başlamış oluruz.
Tamam.
Merhaba.
Merhabalar.
Şöyle. Neyse öyle iyi.
Bizim videomuzu lütfen açabilirsiniz.
Hocam merhaba.
Good morning, merhabalar.
Good morning. Good morning. Sorry.
Mr. Tolga Yenici and Dr. Erdinç Acıkel, they are with us in the afternoon, before the afternoon session 16. The title of the session is Navigating Sustainable Project Management in the Complexity of Maritime Sector. He will now adjust something. Dr. Güneş, thank you. You know, digital technology, it gives you many screens, many connections, many connections. Very good. I would like to thank to Dr. Erdinç Acıkel and Mr. Tolga Yenici that we have already had a few discussions arranging for such a session on project and risk management. I would like to thank all you two for accepting our invitation. On behalf of the organizing committee, I sent our greetings and best wishes from Istanbul. I leave the floor to you. Please also, you are free, please, to give some some Turkish also messages to our students. I leave the floor to you. You know the periods up to 12:40. The floor is yours. Thank you very much. We are watching here. Don't worry, we don't leave the screen. We don't leave the hall, auditorium hall.
Thank you very much.
Thank you.
Thank you very much, hocam. Good morning, everybody. And good afternoon. I know we have audience from different parts of the world. Therefore, I said both morning and afternoon. I would like to welcome everybody and my special thanks to Professor Ahmet Dursun Alkan, who offered us to tell here something about this nice subject. Before we start introducing ourselves, I would like to say a few words about this session. From the moment we shared the topic of this session, we received questions and reactions from different group of people who will be in short-term graduated, who have recently graduated, or who are already junior and senior professionals. That really motivated us, but on the other hand, it made also more complicated to prepare the content and select the topics that we would like to talk in order to keep it interesting and attractive for everybody. So before we start, I just wanted to indicate that we try to keep the content as general as possible, and of course each subtopic is actually a separate item to focus in. I just wanted to indicate before we start. I will keep my introduction as compact as possible because we have really limited time and we have a lot of things to tell. If I might start with my introduction, I am Erdinç Açıkel. After completion of my bachelor degree in naval architecture and marine engineering, parallel to my professional experience, I continued with my academic studies as well. I did my master degree and then also my PhD degrees in naval architecture and marine engineering. And last but not least, I did an MBA, which I finalized last year. So from the professional point of view, I managed several projects in different countries in various segments, such as chemical tankers, fishing vessels, offshore vessels, yachts, dredgers, as in the beginning from the engineering particularly, but then also as overall project manager. So this is about my, as compact as possible about my background. Thank you. And after the introduction of Mr. Tolga, we will also continue with the presentation.
Thank you very much, Erdinç. And thank you very much, Professor. And hello, everyone. Good morning, good afternoon. I am Tolga Energy. I am a mechanical engineer, graduated from Yıldız Technical University. Even though I am mechanical engineer, I am in the shipbuilding industries nearly 20 years now. I mostly worked in ship machinery and equipment manufacturing industry mostly. So I am very much related to shipyards and shipbuilding industry. Most of my time I spent developing propulsion and maneuvering systems. However, I'm also specialized in other equipments such as cranes and windlasses. And lately, I am so much working on project management methodologies, and I try to merge my knowledge from shipbuilding industry and project management industry into one pot. And so this is how this session emerged actually. And I try my best to give you insight about project management in shipbuilding according to most commonly known methodologies in the world right now. And thank you very much.
Thank you. Thank you very much, Tolga. Now, I think in the meanwhile, when you are sharing your screen, maybe I can say a few words as a short introduction. As you all know, actually, the project management is a very general term, actually, which is being used in different sectors. But of course, it needs a kind of dedication and tailoring if you would like to apply it, implement it in a certain sector. In this case, we are talking about shipbuilding, and it certainly needs it's having its own specialties and points of attention, and therefore, for sure, we need to talk about kind of tailoring also in order to make it, in order to match it with the expectations of the sector. We will mainly talk about two topics. The first presentation will be about, in general terms, the project management in shipbuilding, and the second presentation will be focusing specifically in risk management. So I will try to interrupt Tolga as less as possible, but of course, time to time, I will have some things to add from the practical experience, from my knowledge. But I would say, please go ahead and let's start with the first presentation.
Thank you very much, Erdinç. Today, I will talk about project management. Just a moment. I am unsuccessful changing my. Sorry. Is there any problem with my shared screen?
No, it's clearly, it can be
Okay,
clearly.
okay, very well. Okay. So, sorry. So, project management in shipbuilding industry. First of all, I would like to start with what is project. The project, in common term, a temporary endeavor which is undertaken to create a unique product, service, or result. So in our case, it is the shipbuilding, so anything floating on water. When projects come together, they form programs. And when programs come together, they form portfolio. And as end result, we receive a value, which is outcome. So we have a business benefit. The companies either conduct projects or day-to-day operations to reach their business value. So you can have a screenshot, and this is the very general knowledge. You can look at it later. Okay. The project, as I said, project is a temporary endeavor to create a unique product, service, condition, or result. We have a project environment, and our environment is either predictive, or adaptive, or hybrid. What is predictive? Our project is predictive when we know what is the end product is. Like in our case, the vessels. Our project is adaptive when we are not sure what we are going to. Mostly the software industry work in adaptive. They use small increments. They get feedback from customer and they go on. Even though we think the shipbuilding is predictive, actually it's quite hybrid because we don't really use the common predictive project frameworks, and we tailor some components of the frameworks according to our needs. So mostly we are working in hybrid world in shipbuilding.
Yeah, from actually both from product point of view, but also from the approach point of view. Indeed, the shipbuilding sector has more common points with the hybrid construction, because as I mentioned in the very beginning, there are certainly things which should be tailored according to the type of the project that you are building, because it will be a completely different approach if you're talking about, for example, a mega yacht building, or in the naval. If you're talking about a naval vessel, it's completely different than building a chemical tanker or a general cargo vessel, for example, where you actually it is almost fully predictive actually what the end product will be. But on the other hand, in the products that are still, such as the naval vessels or yachts, there are still some unknown facts in the beginning of the project. So you should be more flexible to implement also possible changes, of course, up to a certain level during the project. I just want to add some words on that.
Thank you very much, Erdinç. Why we do projects? Basically for business value and our revenue increase or cost reduction. We have some already mentioned about project approaches. We have predictive, requirements are fixed. We have iterative. Iterative means like making an art. We have only one deliverable, but every time we just do small iterations and add something. We have also incremental approaches. It is like we do something and submit to customer and do the second part. And we have agile approaches which are used when the environment is totally unknown. We just take small steps until deliver what customer requires. I am just passing here quickly because we have more important issues. In this case, we need to tailor our project approach for our shipbuilding project. Tailoring is the deliberate adaptation of the project management approach, governance, and the processes to make them more suitable for the given environment and the work at hand. In the project environment, when we talk about tailoring, we talk about life cycles and development approach. In shipbuilding, the construction of the new vessel may involve predictive approaches for the physical shipbuilding process. However, we may also, in parallel, iteratively approach for understanding and determining the specific navigation and safety systems, for example. So our project approach is highly tailored, specific to every single project. We tailor development approach like iterative or agile or predictive, determining which portions of elements should be added, removed, modified, blended, or aligned to our project. We tailor our engagements because each project we have different stakeholders and they have different requirements. We also tailor the tools according to our project every time, like softwares and equipment I am talking about. Depending on our project, the softwares we are using may differ, such as Microsoft project or like Miro, like Jira. There are many project management information systems. Also, we tailor our artifacts. What are artifacts? Artifacts are template, document, like strategy artifacts, logs, registers, plans, hierarchy charts, baselines. We also tailor all of these according to our project. The tailoring is driven by, of course, the organizational values and organizational culture, and it changes from organizations to organization. And also, in my case, mostly, as I am the PMI member and project management professional, my tailoring is driven by project management principles and performance domains, which are suggested in the project management methodology books. Why we tailor? Because the requirements, as Erdinç said, is so much extensive in nuclear aircraft carrier building than cargo ship building. So even though we are building a vessel, the projects are totally different, and we need a very heavy tailoring specific to projects. The PMI suggests, actually, PMI suggests, like many other methodology makers suggest, there are the logical flow of tailoring process. The tailoring starts with initial development approach selection. Project teams apply their knowledge of the product delivery cadence. I mean, how often we deliver our goods, and awareness of the available options to select the most proper development approach for the situation. And later, we tailor for the organization. Organizations may establish different process governance, and the tailoring, the project must align with their organizational values. And after doing that, we tailor according to our project what we consider in our project, of course, product and deliverables, the capacity of our project team, and of course, the cultural environment. I mean, it is not the same building the vessel in China and in Turkey. There are cultural impacts. And later, our tailoring actually is ongoing process during the project, which we call it progressive elaboration. The issues may arise during the project, and according to issues, we may change our project's style a bit. We may start working more adaptive. So tailoring from the beginning until the end, non-stop going on. For tailoring, we have some considerations given in.
Sorry,
yeah.
Tolga, but maybe we can maybe better continue with the principles indeed considering the time.
Okay, we have some principles and project performance domains during tailoring for consideration. The principles. What are the principles? The principles are the fundamental bedrock of any profession, shaping strategies, guiding decision making, and aiding in problem solving. We have some principles to decide these facts. These principles often form the foundation of constructing professional standards and methodologies. And these project management principles have evolved through the collective efforts of the project practitioners worldwide. For me, the most common project principles used in shipbuilding industry is recognize, evaluate, and respond to system interactions, enable change to achieve envisioned future state, effectively engage with stakeholders, optimize risk responses, tailor based on context, focus on value, navigate complexity. So what are they? The system interaction is basically during our project, we have internal project environment and external project environment. Internal factors can arise from organization, portfolio, or program, or another project, or the combination of all of these three. And they include process assets, data assets, infrastructure, resource availability, and employee capacity. External project environment, external to organization, it enhance, constrain, or they have neutral influence on our project. What are they? They are like marketplace conditions, regulations, industry standards, and physical environment, of course. So we need a system thinking. A system is a set of interacting and interdependent components that function as a unified whole. The project is a system in that interdependent and interacting domains of activity. System thinking entails a holistic view of how project parts interact with each other and external systems. Our next principle is change to achieve envisioned future. This is a structured approach for the organizational transition to the future state.
Maybe it is in this point. Maybe it is interesting also to talk about the navigating the complexity, which you mentioned on the next slides, because it also includes several aspects like such as human behavior, system behavior. Maybe we can also mention some words about that.
One of the most important principle is navigating complexity. during our project, we have complexities. They arise from human behaviors, system behavior, of course, uncertainty, ambiguity, and risks, and technological innovation is a characteristic of a project and its environment, and difficult to manage due to human behavior, system behavior, uncertainty. And the complexity can arise any point of the project. So we really need to non-stop observe the complexities during the project, and we need to do some approach. I mean, there is not really common practice to manage complexity. It is so much, as you know, Erdinç, depends on the experience of the project manager to solve complexity. Project teams usually cannot forecast complexity because it has many root causes. We just need to be careful about complexity, allow project teams to adapt their approaches and plans to navigate potential disruption to effective project delivery. And of course, optimizing risk responses. I will talk about this in risk management part. So I just passed this part. We have some project performance domains. These are the common performance domains for all projects. We have development approach, life cycle domain, planning, project work, delivery, measurement, uncertainty, and stakeholder domain. I pass stakeholder performance domain. This is about stakeholder, engaging with stakeholder. Development approach and life cycle, I already mentioned a bit. This is about the choosing the right development approach and life cycle specific to our project. This is planning performance domain is about the project management plan. And this is what we do at the beginning of every shipbuilding project. What we consider, what is the scope being delivered by the project, scope, schedule, budget, resources, physical, human resource, and what is our schedule. This is all planning performance domain. Project work performance domain is about keeping the project team dedicated and activities running correctly. This is totally human management performance domain. And we have delivery performance domain. This is about monitoring and about quality, actually, because our project delivery is about to meet requirement, scope, and quality expectations. It entails all these quality activities. And
I think you have also the lessons that can be learned from this part. You have also summarized very well in the last slide. Maybe we can also mention that before we go on with the risk side.
About lessons learned, yes.
Yeah, in the last slide, you mentioned some bullet points, maybe of this presentation.
Okay. We have measurement. Actually, at the beginning of the project, we, as you very well know, Erdinç, we have some baselines: scope baseline, cost baseline, schedule baselines, and we determine some thresholds during our thresholds to check during our projects if we are within our limits or out of the limits. The most important thing here is, I believe, this is which is written in red, thresholds. Some of the thresholds, some of the measurements can be out of our thresholds. So at the beginning of the project, we also need to make some plans about what we will do if our measurements are out of our the envisioned plans. This is what I'll talk about. we have lastly uncertainty performance domain.
Sorry that I interrupt, Tolga, but let's go to the last slide, please. Otherwise, we will not have sufficient time for the last presentation.
Okay. This is uncertainty we will talk about. And once we tailor our project, we have some how we will follow our project. We will precisely outline the project scope and objectives, create comprehensive project plan and roadmap, share the project plan with the relevant stakeholders, recognize and address potential risks and obstacles, set specific benchmarks and key milestones, continuously track and evaluate the project's progress, and commemorate achievements and drive lessons from setbacks. Yeah, this is basically, it's been very quick, but this is what project management in shipbuilding is about.
Yeah, I think this page, especially this slide, summarizes very well, Tolga. Thank you very much for your explanation for the first part. Maybe now we can go on with the second topic. In the meanwhile, when you're opening the presentation, maybe I can say a few words about that. Of course, the project management has many aspects, which is also quite important, and the project managers should know about the details of that specific part. Now, we will talk also shortly about the risk management part of the project management, which is only one aspect actually of the project management. But let's start, I will say.
Okay. Risk management, actually risk management has very standard procedures all around the world. I mean, if you know the basic stuff, you can do risk management. The important thing about risk management is the quality of your data. I mean, if you have correct data and correct measurement, I mean, benchmarks, you can make much more healthy risk management. Anyway, this is, I just pass here because, yeah, in risk management, we are fighting with the unknown. If we don't have any information at all about anything, what will happen and what will affect our project in the future, it means we are working in unknown risk area. If we know everything from the beginning, it is not risk anymore, and this is the fact problem, and this is the issue. So we need to solve that issue. So risk management.
This is actually what you mentioned is a really crucial fact that most of the time it's being confused actually within the projects. I've also experienced that in the project that I have participated. That what is actually, if something is already known, in an example, if you already know that the main engine will be delayed in delivery, it's not a risk anymore. It's a fact. That's something that you should count in your planning actually. The main engine will be late, so you should put the relevant section drawings on hold or partly on hold. You should put the relevant foundation drawings, system drawings on hold. So all this is a fact. This is a very crucial thing, which is most of the times mixed actually. But there is a serious difference between a fact and a risk.
Yes.
And talking about the risk, when you are considering the risk as a project manager in the beginning of your project, it is quite important how much experience the shipyard is having about that specific type of vessel. If the shipyard has already built, let's say, 20, 30 chemical tankers in different sizes, they are already familiar with the type of the risks that we will be facing with. But if you are talking about a shipyard, for example, who built always passenger boats and for the first time will build a dredger, then this is a complete new segment they will dive in, and therefore they should recognize also many other things as risks in the very beginning when they are making their risk management plans.
Yeah, From 0 to 100, this is the word of the risk. Basically, when we say risk management, we are fighting with the shadows, to be honest. The things that are not happened, that have not happened yet, but might happen and affect our project positively or negatively. And question, the risk management asks these 6 questions, actually. This is what risk management is. What am I trying to achieve? What might affect me? Which of these are the most important? What should we do about the most important ones? And did it work? And if it worked, what has changed? This is the risk management. And in methodologies, standard methodology, PMI, also the others, risk management consists of 7 process domains. We are planning, identifying risks, performing analysis. After performing, we plan our risk responses, and during execution, if risk emerges, we implement our risk responses, and from the beginning until the closure of the project, we non-stop monitor our risks and update our risk lists. And in every process of risk management, like identifying risk, performing qualitative risk analysis, we have input tools and outputs to use. Input, what information should we analyze? How do we transform this information? And what information we produce? Once we have some critical success factors. First of all, the risk management is iterative. Means it starts at the beginning of the project and non-stop develops until the end of the project. And once we have risk management plan, now we have rules about how to manage risk, procedures, templates. We have roles, who is responsible about risk, and about what to do.
So, Tolga, actually what you are saying is it is a living document, actually, from the very beginning till the end of the project. And of course, during the time, some risks may become a fact and not a risk anymore. So they should be recognized and implemented in the budget, in the planning as a fact, but not a risk anymore. But there may be also new risks that should be counted. For example, in the middle of the project, you foresee a risk for the delivery period or a commissioning period. So they need to be also implemented. So it's a live document, actually, which needs to be updated time to time, frequently during the project.
Yes. The large number of risks in any project are related to stakeholder management and assumptions. Actually, please take screenshot because this is very important. We have risk because of people and the assumptions we do at the beginning of our projects. Of course, when we make our risk plans and list, we check the country context, the microeconomic information, political information, social conflicts, also execution roles and responsibilities, organizational processes, also about our project, stakeholders, assumptions, agreements. These are all source of our risks. Once we have risk identification, considering all these facts, now we need the high quality risk register document. But what is a high quality risk document? The high quality risk document means the information and data inside of the document is correct. It is not just imaginary and sci-fi. It is based on the facts. How? We have a risk statement. Our risk statement, it should be smart. Smart means we need specific information. Our information needs to be measurable, attributable, realistic, and time-bound. I give you an example. For example, we ask the question if the tariff for importing technological products for our vessel is approved within the next 2 years, the cost of the plant's equipment will be affected and impact generating cost overruns of 15% in the project budget. So, yeah.
I think we can skip the other 2 examples then, due to the time limitation,
Okay.
and continue with the next slide.
Okay. And let's say
You have only 1 minute according to the schedule we decided.
okay.
10
Then
days ago. Thank you.
just give this example and finalize then. Let's say we have contingency reserves at the beginning of the project. If the impact is 15% and our contingency reserve is 10%, this risk has high impact. But if we have 30% contingency reserve, this risk has low impact. How do we visualize this? This is the most important part for the students. We have probability and impact matrix. Please take screenshot. This is the most common thing you ever see in your risk management life. So Erdinç, I believe we covered the most important parts of risk management. The rest are so detailed, and we have no time, I believe.
Maybe you can go to the last slide, as it can stay on the screen, Tolga.
Last slide.
Yeah, please.
Which one?
Last slide, just for the email addresses. Yeah. Then,
Ghosh, thank you for your connection. In 1 minute, our colleagues complete their session, their presentation. Thank you.
And thank you all so much listening. You can contact and ask any question. We have our emails, and we had limited time, and we tried to cover as much as possible in this limited time. And thank you for opportunity, Professor and Erdinç.
I would also thank you a lot, first of all, to you, Tolga, in short term for your preparation. Yeah, as you may have noticed, actually, there were a lot of things to talk about the project management. And this in limited time, we did our best to mention some of those. Hopefully, in the future, if there will be a need, if you have any questions, you can always, of course, always contact with us through these email addresses. And of course, if you also have any requests for the future, any needs that where you need some more explanations, you can also contact with us.
Thank you very much.
Thank you very much.
Thank you very much.
Thank you very much. Thank you.
This is very, very important, especially the students, the subject, the project management, risk management, all these large area. Of course, you have spoken for in a limited time. In Turkish, also, I can suggest your subject to the students. Değerli arkadaşlarımız, lütfen Erdinç Açıkel ve Tolga Yenici ile her zaman irtibatlaşabilirsiniz. Mutlaka konunun detayları var. Şey yapmayınız. Sunumlar sonrasında da irtibat kurunuz lütfen.
Thank you so much for your presentation. It
you.
was a great presentation for us, and I think for all the participants. And thank you so much.
Thank you very much.
Now I thank a lot to Meenakshi Ghosh from India. On time, she's with us now. The floor is yours. Thank you very much for your connection. Hello from Turkey. Where are you now?
I'm in India. I'm from Kolkata, West Bengal.
Which city, excuse me?
It's Kolkata. The state is West Bengal.
Very
It's famous for Durga Puja, which we have recently, just the next week. It's famous for Durga Puja. Yeah.
You have 20
I've actually
minutes.
joined from 2 devices. I will share from one, and my video will
Very
go
good,
from
very
now.
good.
Thank you.
It's very kind of you. Her presentation is effect of passing loaded mass through a submerged circular cylindrical pipe bridge in a two-layer fluid in front of a cliff as a vertical wall. I mean, she would, yeah, we postponed this presentation to this session. You can start and please, you have 20 minutes, just 20 minutes. We leave the floor to you.
Thank you so much. I thank you all and International Naval Architecture Maritime Symposium for this opportunity to share our work titled Effect of Passing Loaded Mass Through a Submerged Circular Cylindrical Pipe Bridge in a Two-Layer Fluid in Front of a Cliff as a Vertical Wall. It's by myself and my supervisor, Professor Dilip Dash. I'm from Department of Mathematics of Tamil Harbor Women's University, which is in West Bengal. Before I talk about our work, let me present before you a report from India's Times Now of May this year, mentioning India's first undersea twin tunnels in the Arabian Sea that is set to open next month. Also, the Turkish newspaper Daily Sabah mentions about the Great Istanbul Tunnel construction that is under the Bosphorus at a depth of 110 meters under the bed. It's the world's first three-level tunnel, and it's the third to connect Europe and Asia and scheduled to open in 2028. Also, I want to mention that Fehmarn Belt Tunnel is the world's longest immersed tunnel of length of about 18 kilometers. It will be ready to open by 2029. Such immersed tunnels started from the successful construction of the Thames Tunnel in 19th century. Such tunnels and pipe bridges are either immersed on the bed of the water bodies or submerged or placed at a depth below the bed. So these are constructed to improve the connections of roads, railways, electricities, and water supplies across the water bodies. But there have been plenty of proposed plans and research work on wave interaction with submerged cylinders for the successful construction of submerged floating tube bridges. Among the various methods that have been used for these studies based on linear wave theory, the method of multiple expansion was introduced by Dean and Ursel, and it has rapid convergence. Also, we know that fluids are generally density stratified. It may be due to the differences in salinity, temperature, concentration of various solutes, or a combination of these factors. Thus, fresh river water might float over saline oceanic water, or warm salt water, being less denser, might float over colder fresh water. Wave propagation in such a density stratified fluid was first studied by Stokes, and Lamb discussed the linear motions which occur in this fluid. In 1985, Linton and McIver discussed the wave interaction in such a density stratified two-layer fluid with horizontal cylinder as an obstacle, and Feng et al. In 2008 studied the interaction of linear waves in the same two-layer density stratified fluid model, but with an array of the similar obstacles. And verifying the quote that if you don't think about the future, you cannot have one, 2019 Telegraph report mentions about the Norway's plan that is to construct a submerged floating tunnel consisting of such horizontal circular cylindrical structures, which are two parallel structures. And these submerged floating tunnels are suitable construction for large depth fjords. Also, since submerged floating tube bridges or tunnels cover long distances across the fluid, we must consider that sea cliffs are present. This is the following global map showing the cliff likelihood, and we see that in the mid-latitudes, they are more compared to the tropical low latitudes in both hemispheres. Such cliffs, which are vertical or nearly vertical, are modeled as a vertical wall in the study of wave interaction problems. Also, these vertical walls are used as breakwaters for protection of seashores from waves or for berthing and transport facilities. Recently, there has been an increasing interest to study wave interaction with submerged structures which are placed in front of a vertical wall that is in a bounded fluid domain. But the fluid was considered of uniform density. Since density stratification is a common feature of the geophysical flows, we must study these investigations in a density stratified fluid model. This motivated us to extend Lian Liu 2020 that discussed the wave diffraction and radiation problems by a submerged horizontal circular cylinder in front of a vertical wall that is in a bounded fluid domain, but in a uniform density fluid, to investigate our present problem, that is the effect of cylinder's motion due to passing loaded mass through it when it is placed below the interface in a density stratified two-layer fluid in front of a cleave, which is presented as a vertical wall in our problem. We assume that the submerged cylinder is of infinite length, thus its circular cross-section gives us the following model. In linear water wave theory, a small motion amplitude wave propagates in this two superposed incompressible and inviscid fluids of densities ρ1 and ρ2, where the lower layer is denser since ρ2 is greater over here, and any effect due to surface tension at this interface between the two fluids is neglected. Also, we see that the upper fluid is of uniform finite depth h, where the lower fluid is infinite depth, and where this infinitely long horizontal circular cylinder is fully submerged below the interface in front of this infinite length vertical wall. Here, the vertical wall reflects wave. This is the idealized sketch of the wave-cylinder wall interaction problem. To study this, we apply a right-handed Cartesian coordinate system with the origin on the interface, an x-axis located horizontally on the interface pointing to the right side, and z-axis located is vertically upwards along the vertical wall, with z equals to 0 as the mean position of the interface and z equals to h as the mean position of the free surface. The circular cross-section of the cylinder is of radius a, and the center of the cylinder is at a submerged depth f below the interface and at a distance b from the vertical wall. In a two-layer fluid and a time harmonic wave with a particular frequency in linear motion propagates with two distinct wave numbers, capital K and small k. Here capital K is the smaller one. When these two are exactly two real positive roots of the dispersion equation, which is given as follows, and they are related by the following relation. Here sigma has this form where rho is the density ratio of the upper and lower layer, and thus it is less than 1. When on passing loaded mass through this submerged cylinder, when it is below the interface, it experiences vibrations and radiates wave in all the directions of the fluid when the fluid is otherwise still. Literature says that such vibration of submerged floating tunnels are studied by its translatory oscillatory motion along the x-axis known as swaying motion and translatory oscillatory motion along the z-axis known as heaving motion. We solve this problem based on image principle. Thus, this problem is transformed into an equivalent problem containing two submerged circular cylinders placed horizontally below the interface in an horizontally unbounded fluid domain, as there is no vertical wall this time. And the cylinders are named as cylinder 1 and 2, where cylinder 2 is the image of cylinder 1 concerning the position of the vertical wall. But the vertical wall is not over here. This is an horizontally unbounded fluid domain. Thus, the distance between their centers is twice b, and these are the following centers of the cylinder, giving us this model to work on. Our problem is to compute the non-dimensionalized added mass and radiation damping that will cause due to the radiated waves by the swaying and heaving motions of the cylinders. And we solve this problem, which represents our wave radiation problem. The local polar coordinate system for cylinder L in this exit plane is given as follows. And we assume the motion to start from rest so that it is irrotational. Thus, and it is sinusoidal in time with a particular frequency omega. So the fluid velocities are given by the following time-independent complex valued potential functions, phi1 and phi2 in the upper and lower layer fluids respectively, which using the equation of continuity satisfies the following two-dimensional Laplace equation throughout the fluid region. This is the governing equation of our water wave problem. Now, on computing this completely mathematically, we have certain boundary conditions, where these two are the linearized boundary conditions at the interface of the two fluids obtained from continuity of normal velocity and continuity of pressure at the interface respectively. And here rho is the density ratio, k is wave number, g being gravitational acceleration. Then using the dynamical boundary condition at the free surface obtained from Euler's equation of motion under the theory of linearization, and using linearized kinematic condition at the free surface, we have the following linearized boundary condition at the free surface. And then we have this no motion condition at the bottom at infinite depth. This represents our boundary value problem, which we will solve using the multiple expansions method. When the cylinders are submerged in the lower layer, following are the symmetric and antisymmetric multipoles, and they satisfy the boundary value problem. Here, this is singular at the center of cylinder L. Thus, we have the following integral representation for this, and since we have the cylinder below all the other boundaries of the problem, following is the integral representation as z is greater than f. Now, using the boundary conditions on these multiples, we have A, B, and C, and all the integrations over here are intended to pass beneath the singularities capital K and small k. Now, using the Taylor's expansion on the multiples in the lower layer, we have the following form where n is expressed as follows. Again, we have this expansion where RGL theta GL is the coordinate of the center of cylinder L in terms of the polar coordinate system RJ theta J. Thus, for the cylinders 1 and 2, we have the following values, which we'll use. Again, using Taylor's expansion for the cylinders when J not equals to L, the multiples in the lower layer are expressed in the following form, where D and E are, have these expressions. Now, when we consider the imaginary problem and the cylinders are swaying with unit amplitude in opposite directions in this horizontally unbounded fluid domain, following are the structural boundary conditions of these cylinders. And we have this structural boundary conditions when the cylinders are in a heaving motion with unit amplitude in the same direction in this horizontally unbounded fluid domain. For the solution, we have the following potential functions of the swaying and heaving cylinders in the lower, when the cylinder is in the lower layer, and which is expressed as a linear superposition of all the multiples in the lower layer in terms of the unknown complex coefficients, which we will determine using the following body boundary condition, which we have previously mentioned. Here, the potential functions of swaying and heaving cylinders are substituted, and then by multiplying both sides with the following trigonometric functions and then integrating as follows, we applied the orthogonality of trigonometric functions and obtained the following two pair of infinite systems of linear algebraic equations in terms of the with the unknown coefficients. Following are for the two problems with swaying and heaving cylinders respectively. Now, these unknown complex coefficients are determined numerically by solving each pair of these equations simultaneously by truncation method. After obtaining these unknowns, we compute the hydrodynamic forces, which is by integrating the dynamic pressure over the body surface.
Sorry, you have 5 minutes. Excuse me, you have only
okay.
5 minutes, please.
Okay, thank you.
5 minutes, thank you.
Thank you. Where this are substituted for from the swaying and heaving potential functions and are calculated by the obtained values of the unknowns. And the real and imaginary parts give us the added mass and damping coefficients. Their non-dimensionalized forms are obtained from this expression. Now, since we solve this by truncation method, we have to verify the convergence, and we know that multiple expansion has rapid convergence. Thus, we easily get the truncation number at 3. For all the numerical examples, we have the density ratio as 0.5 and the uniform depth of the upper layer as 3. Now, to study the effect of different spacing between the cylinder and the wall on the non-dimensionalized added mass and damping coefficient, we considered this as the submergence depth of the cylinder, and we plot the graphs for non-dimensionalized added mass and damping coefficient against the wave numbers for both swaying and heaving cylinders. We notice here that they have an oscillating behavior, which is unlike for an horizontally unbounded fluid domain, and this oscillation increases as the frequency of oscillation increases as the space between the cylinder and the vertical wall decreases. Also, at a large spacing, we see that a rapid alteration is observed. Now, at a smaller spacing, we see that the dimensionless added mass has a smaller negative value than the others. whereas for heaving ones, they have more negative than the swaying ones. Now, for the damping coefficient, when the distance is more, we see that the extremes of the curves are more prominent than others, and the radiation damping oscillate about 0 and finally they vanish after a certain wave number. Now we study the effect of different submergence depths of the cylinder on this by taking the distance between the cylinder and the vertical wall as 10, and we plot the graphs similarly for the swaying and heaving cylinders. Here, this represents the larger submergence depth, and we notice that the extremes of these curves decrease as the submergence depth increases. Also, we see interestingly that this the added mass returns periodically to their initial value, and damping coefficients return periodically to 0 for every distinct submergence depth at the same wave numbers. And also, they reach their local maxima and minima for every distinct submergence depth for a particular figure at the same wave numbers. With all these findings, we conclude our work mentioning a report from Season PR Newswire of 2019 that mentions about such submerged floating tunnel construction, which is in conceptual stage in the Arabian Sea by the National Advisory Bureau Limited that will connect United Arab Emirates and India, China, and Pakistan. But another study of Indian coastline shows that the west coast of India contains cliffs in the Arabian Sea. Thus, our present study of wave radiation problem, studying the submerged floating pipe bridge in a cliff-bounded and density stratified fluid model, has a vivid place in research, where we have obtained the dimensionless added mass and radiation damping for the radiated waves due to swaying and heaving motions, both analytically and numerically, using the image principle and multiple expansion method. And we have noticed that when we plot the graphs, they have an oscillating behavior, which is unlike or different from the horizontally unbounded fluid domain. And this frequency of oscillation increases as the distance between the cylinder and the vertical wall increases. Also, we see that when we plot the graphs for the different submergence depths of the cylinder, the peaks of the curves are more when the cylinder is closer to the interface. However, the negative value trained of these hydrodynamic coefficients for the radiated waves require further studies. This present study can be extended to study the same model when the cylinder is above the interface or when it intersects the interface. This is a very interesting one. Or this cylinder may be substituted by some other various geometrical configurations, considering a density stratified fluid of 2 layers with a vertical wall. Or this density stratification may be extended to study a 3-layer fluid model. We recently have some papers with 3-layer density stratified fluid models. Following are the literatures that we have used for our present study, and I thank everyone for their kind attention. Thank you.
Thank you very much. If you cancel the screen sharing, please. If you, is there any question? I don't know. I haven't got any question on YouTube. If there is.
This is actually a very different topic related to submerged floating tunnels.
Can you speak slowly, please? Can you speak slowly, please? Is there any question in YouTube? Let me check. No, there is no question. Of course, your model, your problem is complicated, and you studied a lot. I really, on behalf of the community here, on behalf of the colleagues and the organizing committee, I thank you for your contribution to our symposium. I should say something. Miss Meenakshi Ghosh is from Diamond Harbor
Women's University and its Department of Mathematics.
I am reading because your voice is coming a little disturbed. I am very sorry about she is from Diamond Harbor Women's University, West Bengal. His department is Department of Mathematics. She is research scholar there. I should also congratulate her. His communication, he's writing a letter with all details. I mean, a very promising, a very successful researcher. I see you. I should tell it. Is there
Thank you
any
so much.
question to Ms. Minakshi Ghosh? No. So please, if you tell us just one, few words, but very slowly, please. We are closing.
Okay. Yeah. Okay. This symposium was very efficient, and I interacted with you all a lot for this symposium. That gave me more information and knowledge about the international symposium, and it's very grateful to be a part of this, where it is morely based on engineering things, where we study applied mathematics. It is the basic of engineering. I can understand that.
Very
But
good, very good. Have you watched, in India, they watch our live broadcast, yes? Of the
yes, from
symposium?
YouTube.
Very good.
I have been there. Yes.
So we all applaud.
Thank you so much.
Hope
Thank
to
you.
meet you again. Bye-bye.
Yes, I also hope to meet you personally in France. Yeah, thank you.
Your background view is also very appreciating.
Thank you, sir.
Bye-bye. Thank you.
Bye bye.